Whether the CRs of all 4 sections are present in the call now? CRs, are you present? I just wanted to know whether CRs are present in this session right now. May I know whether CRs are present or not? Yeah, 572, you are the CR. Okay, J not. Remaining CRs, three CRs are right now available. 4 sections, we have at least 1 CR from each section. Right. So at the end of the class, I want CRs to stay back. We would like to have a small 5 to 10 minutes meeting on one important issue. If remaining students also stay back, it's not a problem for us. If all students can stay back for 10 more minutes, we don't mind. It's not a problem at all. So it is not something confidential or secret which will be discussed only with CRs. It's not like that. So if you want to stay back, you can stay back, everyone, right? But CRs, please stay back after class. We need to discuss one or two important issues, right? And if other students are also interested, they can stay back. That's not a problem, right? So let us get into our topic. I've shared my screen. So first of all, we will try to understand this one. Yeah. So yesterday we have discussed what are the design issues in a learning system. In fact, we were discussing it from past 2 classes. And yesterday we have identified some 7 or 8 important points, right? So today what we will be doing is we will also take up an example, because design issues of a learning system is very, very important, right? So these design issues, we will take up an example and we will try to again revisit these 8 important points, right? Because it is expected question and you need to write with example. Simply writing these 8 points is not enough. You have to give an example, right? So that will be discussed today. But before that, we will first of all go through this topic. We will understand this. It's a small topic. Then we will move on to the case study of checkers game, right? So perspective and issues in machine learning. What do you mean by perspective? English meaning, general English meaning of perspective. What is the general English meaning of perspective? Anybody? English meaning of perspective. What is perspective? Perspective means the way you look at something, right? For example, I look at this present lockdown. For example, if you take up lockdown, I look at lockdown as a only option in order to reduce the impact of COVID-19. So this is my viewpoint. The way I look at lockdown, as it is something good which will help us in reducing this uh, 5 year. Yeah, view of something. I'm not. You're right. So view of something is perspective, right? So the way I look at something, you people may look at lockdown in a different direction, right? You may think, sir, it will create huge problems for the daily working laborers, migrants, right? Some people may think that lockdown is making people more and more lazy. Like that, everyone will have a different viewpoint. So similarly, what is a general common perspective towards machine learning, right? What's a common perspective of people towards machine learning that we try to understand. One common perspective, right? Then what are the issues in machine learning? So these 2 points, perspective and important issues of machine learning, we will try to understand now, right? So that's the reason it is clearly written. See here, one perspective, right? One perspective means one viewpoint, right? Not, it's not like that everyone should look at machine learning in the same angle or same viewpoint, right? But one of the common perspective on machine learning is that it involves searching a very large space of possible hypotheses to determine one that best fits the observed data. Friends, I am not in a hurry. We will try to understand every concept, then only we will move to the next one. So please try to understand this statement, then we will go to the issues part. So what do you mean by one perspective is that it involves searching a very large space of possible hypothesis. So what do you mean by hypothesis? What do you mean by hypothesis? This is a mathematical term, generally comes in statistical maths. Hypothesis, probably in your P&S you might have studied hypothesis. I'll give you an example of hypothesis. Since all my classes are being conducted online, there is no serious monitoring of how many people are really attending. So there is no serious monitoring, and even in the online mode, we are sitting at home. There is no control, like anytime anybody can skip the class saying that there is a technical issue, all those things. So because of all these circumstances, the outcome of online education will be very, very poor. This is an hypothesis. So hypothesis means it's a statement which can come true or which may not come true. So hypothesis means it's a belief based on certain facts, right? It's a belief based on certain facts, and we try to prove it. So I think that online education is relatively or comparatively is not so effective when compared to physical classes, offline education, and it may have a, tremendous ill impact on the results. This is what is my hypothesis. Now, whether this is true or false, who will tell me? Over a period of time, based on the exams results, it has to be proved whether my statement is true or false. So hypothesis means a statement which we make based on certain facts, and that statement may become true or false. So what do you mean by hypothesis? Is it correct? Is it clear, sir? Kindly let me know. You understood what is hypothesis? What is hypothesis? Is it clear to everyone? Please respond, my dear students. Please respond. Yeah, thank you. Because see, if you are not responding, I'll not understand what is happening, right? So please respond, because you might have noticed I am not simply running the PPTs. If I am simply running the PPTs, then my job will be easy, but I know very well that it will be of no use, right? So to the possible extent, I am trying my level best to impart the concepts in a manner that like each and every student can understand. So please cooperate with me, make this session interactive, right? I'm happy people are responding. So hypothesis, another example of hypothesis is, for example, it is a game. Let us say it is a chess game. So hypothesis means if this is a horse, then the horse should move only in this direction, right? I'm making a statement. So if this is a horse, then it has to move only in this direction. If it is an elephant, then it has to move like this only. So these are certain hypotheses. Hypothesis means a belief based on certain facts, and it has to be proved in the near future. So coming back to our statement of perspective, we are trying to define what is a perspective, what is a common viewpoint on machine learning, right? So the common viewpoint is it involves searching a large space of possible hypotheses to determine one that best fits the observed data, right? Why we are saying searching a large space of possible hypotheses? This we have to understand. Searching a very large space of possible hypotheses. For example, friends, let us assume that we are trying to develop a machine learning model which can play the chess game, right? So how do you train the model? You have to give the model the experience. So from where do you get the experience? You try to collect the data of the previous games played by various players, right? So suppose I have started the game, like player A and B has started the game. Let us assume player A has won the game. Now, from player A, what we will learn is what are all the possible moves that player A has made. Similarly, that is only one example. If I want my machine learning model to play like a professional chess player, it has to get lot of training experience. So when we start the game, right? When we start the game, forget about the machine learning model for a moment. If you are playing the game also, when you start the game, you have lot of options, right? Suppose you are supposed to make the first move. Either you can move a soldier. Which soldier you will move? You will have again around uh, 8 to 10 options. Or you can start the game by moving a horse. Which horse you will move and in which direction you will move. Like that, friends, whenever you try to make a move in the chess game, you have large space of possible outcomes or possible legal moves. In that, you have to pick the best possible one, or the one which best fits the observed data, or the one which best fits your requirement. See, I want to make a move such that I can win the game, right? So I know how to move the horse. I know in how many ways I can move the horse, but I need to identify what is the best move. Got the point? So from large possible options, we need to pick the best fits. That's the reason, not only chess game, friends. If you observe any other machine learning problem, suppose machine learning is applied in identifying, in object identification. Object identification means I would like to see how many ambulances have passed through one, let us say, one crossroads from Secunderabad Junction. How many ambulances have passed in one day? This is an object identification problem, right? Similarly, if you give me some medical imaging data, I need to analyze and I need to tell whether there is a tumor in that data or not. Classification problem, right? Like that, friends, prediction problems will be there. Machine learning is applied in prediction, classification, identification, recommendation. These are all areas where machine learning is applied. Suppose I want to recommend something to you. Suppose if you are an Amazon customer, I would like to recommend something to you. On what basis I will do recommendation? I need to study large pool of data. I need to study large pool of transactional data made by you, like what are your buying habits, what is your range of expenditure, right? What type of products you have bought, how frequently you buy. Like that, lot of data I need to study, and from that I need to pull out the best possible offers or best possible recommendations to you. Like that, if you observe in all areas where machine learning is applied, it really involves searching a very large space of possible hypotheses to determine one that best fits the observed data. So that is what is the perspective of machine learning. So machine learning is basically, machine learning basically involves what? You have large space of possible hypothesis, and from that you need to pick the best possible one. That is what is a general approach towards machine learning. I think this point is clear to everyone. Now, what are the issues? So this one line is perspective, my dear friends. Then the points which you are seeing here, 1, 2, 3, 4, 5, 6, they are the issues, right? So what are the issues? Issues are what algorithm exists for learning general target functions from specific training examples, right? So as I told you just now, machine learning can be applied in many areas, many problems, many real-time problems. It can be applied in recommendation systems, it can be applied in prediction applications, it can be applied in text processing applications, it can be applied in healthcare, it can be applied in insurance domain, credit card fraud detection, it can be applied in what we say object identification, classification problems, clustering problems. Like that, the scope of machine learning is unlimited, almost unlimited. So for what kind of a problem, right, what kind of algorithm should be applied? So what algorithms exist for a general target function? This word is not new now. What is a target function? We have defined, we have understood this yesterday. Every machine learning model, it will learn with the help of a mathematical function. Learning is done with the help of a mathematical function. If you recollect the examples of height and weight problem, y equal to mx plus c was the function. If you try to recollect the examples of a person going to a movie or not, we have seen one more function wherein we have applied some AND gate OR gate kind of thing based on the choices of the person. Movie recommendation example. So for like that, for every example, for every machine learning problem, we create a function. We call that function as the target function or the learner function, right? So how many algorithms are there? How many different types of functions can be applied for different problems? That is the first issue. Means suppose if you all of the let us assume next semester you want to do a project in machine learning and you wanted to analyze the traffic data from a traffic signal, like how much traffic is coming at LB Nagar junction, and based on that you want to do certain prediction. So how do you analyze traffic? You have to get the traffic data and you start working on it. So what it involves? It involves working on images, image data. So for image data, what kind of machine learning algorithms are good? And for video data, what kind of machine learning algorithms will be good? For text data, suppose if you use Gmail, these days you might have noticed when you start typing something, Gmail will recommend the next word, right? Previously it was not there. In the recent past this feature was added. This is an example of predicting the text, right? Text processing example. So what algorithms, what ML algorithms, machine learning algorithms can be applied there, right? You see some subtitles coming from in a movie, that comes under speech recognition. Based on the speech I will generate that subtitles. So that is another example. Like that, we have variety of problems, friends, and in all these problems what kind of machine learning algorithms can be applied? That is first issue. Second issue, how much training data is sufficient? Suppose if you recollect the examples of heights and weights example, I used only 10 heights and weights. So what should be the size of training data? 10 samples are enough, or 100 samples are enough, or 1000 samples are enough, 10,000 samples are enough? We don't know. In fact, it varies from problem to problem. So this is one issue. You can't say that, you can't even make a statement like maximum possible training you should give. Like that also you can't make statement, because if too much of training is given, it will lead to a problem called as overfitting. It will lead to a problem called as overfitting. We will try to understand this one in our future classes. But remember, so don't be in an illusion like, if I keep on increasing the training, if I keep on increasing the training, my model performance will improve. No, no, it's not correct. It may lead to overfitting. So how much training data is sufficient? It is also an issue. We don't know. We can't tell, right? Similarly, when and how the prior knowledge of the learner guide the process of generalizing. When and how can prior knowledge held by the learner? Suppose learner means machine learning model, sir. Here learner is nothing but machine learning model which we want to create. Right? Every time when we use the word learner, we are talking about machine learning model. So when and how can prior knowledge held by the learner guide the process of generalizing? Suppose the machine learning model can have prior knowledge, means already a machine learning model was created, it was applied on some set of examples. So now an existing model I am trying to apply on a different type of problem. In such cases, the prior knowledge of model can help or not. That is a issue. Sometimes it can help, sometimes it can even create a problem, right? So prior knowledge can be useful or prior knowledge can be harmful also in some cases. So these are all issues because we don't know answers for these things, right? It varies from problem to problem. What is the best strategy? Next point, what is the best strategy for choosing a useful next training experience, and how does the choice of strategy alter the complexity of the learning problem, right? So I told you training experience we have discussed in the last class also. For example, if you take a chess game or any checkers game, training experience, from where do I get training experience? Direct or indirect method. We have two methods. Direct means my program, my machine learning model should play the game with itself. It should complete with itself, play the game continuously, play the game, lose the game, then play the game. So over and over playing, by playing the game continuously, it will learn something. That is one method. Another method, indirect method, is already so many people have played the game. From that experience, from that data, from people who have played the game, that data can be bought and given to the model. That is another option. So what is the best strategy? You have to think. Every time direct method is not recommended. In every case, indirect method is also not suitable. That is the fourth point. Fifth point, what is the best way to reduce the learning task to one or more function approximation problems? See, when we talk about this function approximation, means when we try to derive this target function representation, we should make sure that it should be less complex, right? So what is the best way to reduce the learning task? It should not learn something which is not necessary. So how well you write this approximation algorithms, that is one more issue. Last point, how can the learner automatically alter its representation to improve its ability to represent and learn the target function? This is very important point. Of course all issues are important, but this is very important because see here how the machine learning model, learner means ML model, how the machine learning model automatically alter. See here, it itself is changing its representation. Means suppose initially I gave a function and I started using that function, right? Maybe initially the performance of the algorithm was 60%, and now my algorithm, based on the training experience, slowly it is trying to learn, and it has observed that there is a need to change the function. So automatically, if my machine learning model can change its representation means the function which we are going to write, the learning function, right? So how the machine learning model automatically alters its representation to improve the ability to represent and learn the target function. So how it can be done automatically, that is also an issue, right? So like that, we have 6 important points under issues in machine learning. So one is perspective, means how do we look at machine learning, and another one is issues in machine learning. So these are the 6 different points, my dear students, right? So this is perspectives and issues in machine learning. Designing a learning system, those important design issues we have discussed in the last class. Now we will try to apply those design issues on one example, and that example will be a checkers game, right? So first of all, let us try to understand what is this checkers game, right? So please look at this video. I am trying to play a YouTube video, right? Are you able to see this? I am trying to play a YouTube video. Are you able to see this? Just type in chat box. YouTube. Yeah, that's great. Fine. So I'll try to play this from the beginning. How to play checkers. The video was not audible. No issue. There was nothing explained in that video. Only by looking at the video we can understand how to play the checkers game. So you got some basic idea of what is a checkers game and how to play it. Please tell. I hope you understood how to play checkers game, right? Right. So now we will go back. See here. These are the important design issues of a learning system which we have discussed in our previous class, right? Now we will try to apply that. We have 8 points, right? We will try to apply that on checkers game. Now this is the case study. This is what we wanted to discuss. So you will get a question like explain design issues of a learning system. This can be essay type question. So when you get this essay type question, observe this carefully. You have to mention these 8 points, design issues. These 8 points you have to mention. Then again you have to give an example. That example is what we are discussing today now, right? Of course I'll put it together in the form of notes, don't worry, right? So designing a learning system, case study. What is the case study? It is playing checkers game, right? Now, what is the first design attribute? As per 8 points, what is the first design issue? Training experience. So, in checkers game, now whatever 8 points are there, I am trying to apply those 8 points here in the checkers game. So, the first design attribute is training experience. From where I can get the training experience in checkers game? Come on, please tell me. From where I can get the training experience? From where I can get training experience? Please respond, my dear. From where do I get training experience? My machine learning model, if it has to play the checkers game, it should be trained. So it can get training experience in two ways. One is direct and another one is indirect method. Direct method means it should start playing with itself. Yeah, collecting data 572, that is good point. It comes under indirect method. So direct method is you start playing with yourself. The program plays with itself and it will try to learn from the experience. That is direct method. Whatever 572 has mentioned, collecting data, that is also correct. That is indirect method. So what I will do, I will try to collect the data. Suppose in checkers game, let us say there are so many great people who have played checkers game, like champions are there. I'll try to get the data from those champions, right? Mr. A, B, C, D, how many games they have played. I'll try to gather maximum data, and from that data, okay, suppose Mr. A and B have played the game, A has won the game. So what A has done? What was A's first move? What was A's second move, third move? Like that, till the last move, what A has done. I'll try to teach this to my program. That is what is machine learning, my dear. Similarly, I'll try to get the training data from another example where X and Y played, X has won the game. Fine. So this is called as collecting the data, indirect method, right? As rightly said by 572. Fine. So training experience. So from the first attribute, training experience in checkers game, how do I get training experience? I get from direct method. Another one is indirect method. But in indirect method, there is a problem. The problem is credit assignment is a problem. What do you mean by credit assignment? I will ask a question and I'll be very happy if you can respond. Suppose if A has won the game, right, and from the beginning to end, A has made 34 moves, right? Listen carefully. If A has made 34 moves and A has won the game, do you think all 34 moves made by A are equally important? Do you think all 34 moves are correct moves? Maybe he has won the game. It doesn't mean that he has not committed a mistake at all. In all 34 moves, do you think all are correct steps? All are perfect steps? All are best steps? Whether it is checkers game or even a chess game, suppose if you have won the game with your friend, not only some are, no, only some are useful. That's great. So out of 34 moves, it doesn't mean that all 34 were contributing to my victory. Maybe some steps were not correct. right? Out of 34, let us say 7 or 8 times I might have made a wrong move. But because my opponent have committed more mistakes, I have won the game. Please try to understand this. So out of 34, maybe 7 or 8 moves, I don't think they are correct. But still I won because my opponent has committed more number of mistakes. So let us assume out of 34, let us say 10 are wrong moves. So what I left with 24 moves. And in these 24 moves, do you think all 24 moves are equally important? All 24 moves played the same amount of role in my victory? Do you think all 24 moves are equally important? Generally, when we play chess also, at the end of the game we will say, అరే నేను ఇలా ఈ ఒక్క స్టెప్ చాలా బాగా ఆడాను రా, అందుకే నేను గెలిచాను, ఇలా మాట్లాడుకుంటాం మనం, రైట్? So if you observe, all 24 moves out of 34, maybe 10 are wrong steps, and remaining 24, it doesn't mean that all 24 are equally important. So that is the important point to be noted. So if I try to collect some indirect data from previous games played by champions, in that also I have a problem. The problem is which move is more important, which move is less important, which move has contributed more to the victory of the game, which move has contributed less to the victory of the game. So like that, every move should be given some weightage. Every move should be given some weightage, which we call it as credit assignment, right? So friends, is it easy assigning weightage to every move? It's very tough, right? It's very tough because I don't have a single example. I'll get, suppose if it is a chess game, I'll try to get the data from Vishwanathan Anand's previous games itself. I'll get thousands of records. Like that, if I try to get data from various chess players, whatever games they have played, whatever moves they have made, if I try to collect that data, I'll get variety of data. And in that, for every move assigning a credit, giving weightage is very, very tough. That's the problem in indirect training example in checkers game or even chess game. Okay, let us assume it is checkers game. So that is first in attribute, which is training experience. Second attribute is how much control, the degree of control. See, second important attribute of the training experience is degree to which the learner controls the sequence of training examples. Means whatever training data you have, on that training data, how much control you have, that is important. In checkers game, the learner can rely or means learner can depend on indirect training or a teacher to select the informative board states and to provide correct move for each. What do you mean by this? In the video we have seen, right, how many board states are there? There are 12 states. So we have seen the rules, no? In that video it was giving the text, there are 12 states, and it can move only in diagonally. Horizontal and vertical movements are not possible. Only the king who got crowned, only that fellow can move backwards. No other what we say element can move backward. Only forward direction is valid. So like that, who will give this information to your machine learning model? So either you learn it from indirect training or a teacher to select the informative board states and provide correct move for each. So in some or other way, I should give this rules, I should feed these rules to the model. Otherwise it will not understand. Like if it is a checkers game, I should move only diagonally, I should not move horizontally. Who will tell? Either it should learn from indirect training data, or you should write some logic to put those rules. Like each element should move only diagonally. Like that, you should write some logic. So that is the second important point. So then only you will get some control on your training examples. Third important point, Third attribute is the distribution of training examples. I told you in the last class when we were discussing about 8 points, I gave you examples of house prediction machine learning model. In that house prediction machine learning model, if you try to recollect, I gave you an example. My data was from pure urban area, and if I try to apply this model and predict house prices in a semi-urban area, it will not give me correct results. That is what was the example discussed. So the distribution of data is very important. Similarly, in checkers game also, suppose if I got the training data from the players, from 100 players who have won the game, right? Do you think that the distribution is sufficient, or that information is sufficient to train my model? Do you think so? Right? I don't think that if I get the information from only the people who have won the game, if I get the training data of only one category, that is the people who have won the game, only from winners, if I get the data, I don't think my distribution is sufficient enough, because even if someone has lost the game, it doesn't mean that that fellow's each and every move was wrong. Please try to understand that. Suppose if I have lost the game, it doesn't mean that I played completely each and every move was wrong. It's not like that. I might have made some excellent moves, right? Suppose out of my 34 moves, let us assume that I lost the game, but out of my 34 moves, 30 moves were really good. In the last, at the end, because of frustration or tension, I committed some mistakes and I lost the game, maybe something like that. But out of 34 moves, 30 moves were really good. So if I don't consider the data from the people who have lost the game, I don't think I am giving complete maximum different samples to the training experience. Means training experience means it should include everything, all types of combinations it should get. So for that purpose, in our checkers game also, we try to give comprehensive training examples. Don't blindly get the training data from winners alone. Not all moves made by winners are perfect. Not all moves made by losers are incorrect. So try to get the data from both winners and losers and give appropriate weightage, then train your model. That is the third important point. Fourth important point is, fourth important parameter is the target function. So if it is a checkers game, the target function is represented with capital V, right? Uh, right, capital V. In checkers game, the target function V must be such that it should generate a best move, right? From all legal moves, right? Just like our horse example, horse can move in multiple ways. In different possible options are there in my chess game, but I should select the best possible move. Similarly, in checkers game also, I can move diagonally. I have 12 pieces, right? Whether it is white or black, whatever it is, I have 12 pieces. I can move them diagonally, right? Which one I will move, it is my choice. But the important point is, out of all legal moves, I should generate a best move. This mathematical function should suggest me what is the best move. So how do I write this mathematical function? The target function V will be written like this: B determines M. B means board state. Board state means the video which we have seen. Right now, the coin is in which place? Right? Determines M. Determines M means from B. M means move. B means board state. B means board state. And M means move. So B to M means right now I am in which state, and from this state where should I move. So that guidance or that information I should get from this target function. I should get this from the target function. Now what are the possible outcomes of the target function? In target function we only mention the possible outcomes, but how do we reach or how do we represent that target function, it's the next part, next step. So what are the possible outcomes? See here, if B is a final board state and if the match was 1, then V of B is equal to 100. Please try to recollect, in the last class we gave you an example of movie recommendation where the possible outcomes were only 2. If output is 1, I'll go to movie. If output is 0, I will not go to movie. But here I have 3 possible outcomes. I can win the game, I can lose the game, I can draw the game. So if B is the final board state and if I have won the game, then V of B must be 100. Means the output of this function should be 100 if I won the game. Output of the function should be minus 100 if I lose the game. Output of this function V should be 0 if I have drawn the game. So like that, there are 3 possible outcomes. Okay, that is target function. Now fifth point. How do I represent the target function? Function approximation. This is called as function approximation. This is important. Right. So see here. Please observe this carefully. There are certain variables. X1, number of black pieces on the board. X2, number of red pieces on the board. Red or it can be white. In our video, we have seen black and white. Right? It can be black and red also. In some boards, it will be black and red. Right? So these are the variables, my dear. So see here, this is how you create a machine learning model. So X1 represents what? Number of black pieces on the board. Of course, it will be 12. Number of red pieces on the board, same 12. Number of black kings on the board. Right? Number of black kings on the board. King means what? The one who has reached to the opponent's starting state. That first row is there, no? Opponent's first row, the one who reaches, no? That fellow is called as king. And once you become king, you will be crowned with another coin. We have seen in the video. Right? Okadani మీద ఒకటి రెండు పెట్టున్నాయంటే వాడి king అండి. So number of black kings, X3. Number of red kings, X4. And X5, see here, number of black pieces threatened by red. What do you mean by threatened by red? They are facing opposite to each other, and in the next move I can bypass the opponent. So if one black and red are facing each other diagonally, if it is my move, if the red has to move, then red can bypass the black. So threatening means in the next move I can remove that black out of the game, out of the board. So X5 represent number of black pieces threatened by red. X6 represent number of red pieces threatened by black. So if I know all these 6 values, I can represent entire checkers game using a mathematical function. My original target function, this is just saying me what I want. I want the output of the function to be 100 if the model wins. I want the value of the function to be minus 100 if my model loses the game. If I want the value of the function to be 0 if the model draws the game. But how the model will learn, how the model will play, that depends on the representation of the target function. So this is the target function, my dear friends. Please don't get confused. This is target function. This is target function. Target function says that right now where I am, and from here how do I move. Right? Current board state and what is the next move. That is target function. But how to move? How to move? What is the best possible move? What is the formula to identify the best move from all legal choices? For that, this is target function, but in order to drive my target function, I need a function approximation. I need a formula for it, and the formula is this one in this example. So X1 represents number of blacks on the red board, number of X2 is number of red pieces, x3, x4, x5 and x6. Any issue? Yeah. So x1 number of black pieces on the board, x2 number of red pieces on the board, x3, x4 that we have seen. Now this is called as v dash of b. This is our function approximation. Now what I am doing, sir? W naught plus W1 into X1. What is X1, X2, X3, X4, X5, X6? We know. Now for every parameter, see here, we are assigning some weight, W1, right? W1. Weightage is also important. Every parameter is not equally important. So accordingly, weight should be given. And in the last class, I gave you an example of y equal to mx plus c, why that c will be used, that initial bias or additive constant W naught. So if you take up any machine learning model, friends, right, you will see this W naught, that is compulsory. It is the additive constant or bias which we have discussed yesterday. So for checkers game, this will be the function approximation, which is mentioned with v dash. So v dash of the board is equal to, this small b represents the current board state, right? Suppose if you are representing red, right now you are talking about which red piece and where is that red piece. So for current cell, for for red piece or black, whatever it is, for one board state, the formula is like this. So you apply the same formula on every board state. Every state will have a different weight, right? And x1, x2, all these values will change. So v dash of b represents the function approximation. So suppose if I want to create a machine learning model, and if that machine learning model has to play the checkers game, definitely in the background this will be the formula, right? Now how do I adjust weights? From where do I get training data? That we have seen. I get training data in the form of indirect data. With past experiences of the players, I'll collect the data, and based on the importance of the parameters, the weights will change. Initially we will give random weights, right? We will see in future when we talk about weights, all those things in our next unit, right? So this is approximation. Next, last 2 points before we wind up. Estimating the training value. Estimating the training value. Estimating training value means, for example, what do you mean by estimating training value? Means, suppose right now if it is a checkers board, let me go back and I show you this one. I'll mute it. Yeah. Suppose, see here, suppose I am pointing out to one black element or one black coin. See here, one black piece. See the mouse pointer. Suppose I am here. So from this black cell right now, this is my current position. From here, where do I move? I can move this way or this way. There are two options. But in these two options, what is the best one? That training data I want, that data I should, if I am playing, if my machine learning model is playing with a person, right? Now the model has to decide, if I am right now here, shall I move in this direction or in this direction? How the model will decide? It is based on its training experience. So how you will train the model, from where do you get the training examples? For that, the formula here is estimate the training values. V train of B means V train of B. The meaning of this statement is, if I am in so and so cell right now, then from this particular position, where do I move? Now that is calculated based on V dash of successor of B. Successor of B means, please come back. So here right now I am representing this black what we say element or black checker. Now from here, what is my successor? Successor means what is the my next possible state. Either I can go to this cell, this is one successor, right? Either I can go to this cell or I can go to this cell. There are two options. There are two options. Now what I will do is I will compute V dash on this one, my option number one. I'll compute V dash on the option number two also. This V dash can be computed for every cell. That is what we have seen previously in our previous function. So I compute V dash on this one. I compute V dash on this one also. So I'll compute two V dash values, and which one is greater, which one is more effective, that value I'll pick, and based on that I'll decide where to move. Suppose this V dash value I got it as 7 and this I got it as 6. So I'll try to move my black checker in this direction only. Got the point, my dear friends? So this is how you estimate the training values, right? And one last point before we close, one last point is, how do you adjust weights? See here, how do you adjust weights? This function here, these W1, W0, W1, W2 up to W6, these are called as weights, and we need to adjust these weights, we need to modify these weights such that our function will be refined and it should perform well. Its performance should improve. Suppose if the performance is initially 70%, I'll make some changes in the weights so that it should become 80, 85, 90, 95 like that. So what changes I'll make in the weight, how to make changes in the weight, how to make adjustments. For that, there are so many functions, right? Weights are adjusted to minimize the errors. This is the important point. So we adjust the weights to minimize the errors. Weights are adjusted to minimize the errors. How do we adjust the weights? There are so many methods, right? So many methods. This adjusting the weights is done by some functions which are generally called as loss functions, right? Loss functions, so many loss functions are there. One of the common weight adjustment method is LMS, least mean square weight update rule. So what we do is, see here, for all training examples, here sigma represents all training examples. What I'll do is I will see the difference between, right, V train and V dash of B, and I'll try to square that value, square that difference. In order to explain you this, what we say weight function, or what we say loss function, I will give you an example. If you recollect our heights and weights example, prediction example, what we have seen, let me show you that heights and weights example. I think I have closed it. It's not there right now, but I hope you remember that heights and weights example. Suppose if I have created a machine learning model, if that machine learning model is its job is to predict the weight for a given height. Suppose the given height is 6.11 and my machine learning model has predicted the weight to be 87 kgs. But when I cross checked it with the doctor, right, means the original value, doctor told no, for 6.11 the weight should be 88 kgs. Means my program, my model is predicting 87, means the value generated is 87, value expected is 88. So V train minus V dash of B, it is nothing but the difference between expected value and generated value. Difference between expected value and generated value. So what we will do is we will square the difference between expected value and generated value. This is square, right? V train minus V dash of B whole square. Why we will square? The reason is very simple, right? I don't want this difference is nothing but the error, right? Expected value is 88, generated value is 87. So the difference is nothing but it is an error. I should get 88, but my model is predicting it as 87. So it is not absolutely correct. So there is an error. Now that difference should not be negative. So that's the reason what we will do. We will square those differences. When I square, what will happen? There is no chance of getting a negative number. So difference can't be negative, error can't be negative. So we try to square that. So this is generally a very common weight adjustment what we say loss function applied. So this is how I calculate the difference, right? For all training examples, I'll try to adjust the weights using this formula. So V train minus V dash of B whole square, this we will compute, right? So this part, see here, V train minus V dash of B whole square, this we will compute for every training example. And what I will do is, this N is an additive constant again. Generally, it will be some 0.1, 0.2 like that. And this is my Wi. So if I'm updating Wi, means for example it is W1, what I will do, this is existing value of W1, then this is X1, sorry, this is X1. So I will apply this difference V train minus VB of whole square. This formula will be applied. W1 plus N into this what we say error function into X1. Whatever new value I'll get, that new value will become the value of W1, latest W1. So W1 is updated. W1 is equal to old W1 plus this formula. Like that, W2, W3, W4, all weights will be updated. This adjusting the weights will be done till we think that the machine learning model is not giving me the most accurate results. So once it is refined, we will stop that what we say adjustment of weights. So this is an example, friends, where we applied all steps of all design issues of a learning system. We have understood, we have applied it to an existing example, which is checkers game. So first, in the yesterday's class, we have seen what are the design issues, and in today's class we have applied those design issues to checkers game example, right? Is it clear to everyone, or do you have any doubts? Please let me know. Please respond in the chat box. Please respond in the chat box. Dear students, please respond whether you understood the concept or not. All steps of design issues were applied to an existing algorithm, existing example of checkers game. So whether it is checkers game or any other problem, procedure is same. All design issues need to be considered. Come on, please respond. Please respond. Did you understand the concept or not? I know I have taken 10 minutes extra, but please respond. Yeah, D5, yes. Dear students, please respond. Understood, sir. Okay. Fine, fine, fine. Clear, sir. Okay, right. So, friends, so we have seen design issues. We have also seen perspectives in machine learning. And in the next class, we will talk about the next topic. If you just look at the syllabus, right? These three topics we have done with. So we will start concept learning and general to specific ordering. This topic we will start in the next class. And before we wind up, I request all CRs to stay back, right? If other students are also interested they can stay back. I want to discuss with CRs a small quick meeting of 5 to 6 minutes, not more than that. I request all CRs to stay back.